Last time we have seen that proteins are made of units called amino acids, and the proteins differ from each other by the number of amino acids, the type of amino acid, and the sequence, the arrangement. Right. How many amino acids we have in nature, ya Khalid? Aya with us, come in. Okay, how many amino acids we have in nature, if you remember? We have 20 amino acids. Okay, from these 20 amino acids, you can make millions of proteins, depending on the number of these amino acids, on the sequence, and on the type. Now, if I give you a protein, and I want to know, okay, what are the types of amino acids inside it? What are the types of amino acids inside it that make this protein? The process that I will do is called the chromatography. Did you see this chromatography before? Or anything about chromatography before, ya Khalid, or Yusuf, or Aya? Okay, any idea about chromatography? No. Let's see. Let's see what is the chromatography that I will use to separate the amino acids. Okay, to separate the amino acids. Who can read this part, please, from the beginning? Yalla, who can read? Khalid, Yusuf, Aya, Iman. Who can read this part? Iman, next page of what we did last time. Page 74. Page 74.
Yes, I can read it.
Yalla ya Iman. Now ya Iman, we are using this technique to separate the amino acids in a protein so we can identify them.
Okay, يعني بلش من document A?
Yes, please.
Okay, document A, identification of the chemical constituent of proteins.
Okay.
In order to know the different kinds of amino acids that form the protein, peptide or polypeptide.
Faizan, this is the objective of the experiment. Okay?
Yes.
This is the objective, to identify different kinds of amino acids inside a protein. If I give you a protein and I tell you what amino acids are found in this protein, we know that we have 20 types of amino acids.
Yes.
Okay, I want to know what amino acids will be found in this protein. All amino acids are colorless, فإذا they have no color. فإذا even if I put them in a solution, I cannot separate them, I cannot identify them. So I need a technique. The technique now here is called what, ya Iman? Double? The title?
Double chromatography.
Double chromatography, exactly. We have to use double chromatography. Type. Yalla.
Different amino acids have different molecular weight.
Okay, Iman, we will read here slowly because this is a new technique. We need to explain it very well.
Okay.
Please. Okay. First you said different amino acids have different molecular weight. Type. This is normal. يعني amino acids, they are made of different atoms and in different number of atoms. So they
Yes.
have, do they have the same molecular weight? No.
No.
They have different weights لأنه different formula كمان.
Yeah.
Okay, so
So they have different degrees of solubility.
what does it mean solubility يا إيمان? What do you mean by solubility?
Mm,
Solubility is the ability to dissolve.
yeah.
Okay, ability to dissolve.
Dissolve.
You know that not all chemicals dissolve the same way.
Yes.
يعني مثلا you have chemicals that dissolve in water while other chemicals does not dissolve in water, صح؟
Yes.
طيب give me something يا إيمان that dissolve in water.
Salt.
Dissolve in water. Like what?
Salt.
Salt. طيب give me something that does not dissolve in water.
Silver.
Silver, oil,
Yes.
صح? Anything like this. So this means that not all substances dissolve in the same way. Some may dissolve more than the others. طيب,
Yes.
let's see. Continue يا إيمان.
So they migrate in different velocities.
This is very important. They migrate in different velocity. When you put them in a liquid, in water for example, they diffuse in this water, they move.
Yeah.
But they move in different velocities, in different speeds. Some of them are slow, while others are fast.
Yes.
So this is very important. Okay.
Less weight.
Okay, if they have less weight, they will be, continue,
Fast.
more
More soluble.
more soluble. They will be more soluble. Okay, so
Higher speed of migration.
higher speed of migration. Exactly. So they will have higher speed of migration. Okay. Based on this concept,
Based on this concept, we can separate these different amino acids given that they are immersed in a soft fluid that permits migration of different amino acids, each at specific speed.
so what is the idea now, Ya Iman? The idea now that you bring a solvent, a liquid, that will dissolve these
Yeah.
amino acids, and the amino acids will move inside this liquid at different speed.
Yes.
Okay, because they move at different speed, now I can detect how many amino acids I have.
Yes.
So this is the idea now of the chromatography. Okay, this is the idea of chromatography. Type. Okay. Clear, guys? Any question? Any question? فإذا now I will separate amino acids according to their solubility, يعني to their mass, how fast they can move inside this solvent or inside this liquid. Okay? How they can move inside this liquid. طيب. Okay. Any question? تمام. طيب. Iman, we will read, let's say, each box alone. And then we explain it.
Okay.
يلا.
It says اقرا هيك direction of migration.
لا اول بوكس اللي تحت deposit the hydrolyzed protein.
Okay. Deposit the hydrolyzed protein molecule at point O on a specific chromatographic paper. Then immerse it in solvent 1 with a certain density.
فاذا we bring the protein first, we dissolve it, لا we digest it first, يعني we cut the protein into the amino acids. Now you
Yes.
have a mixture of the amino acids. Okay, now we have a mixture of the amino acids. Then we
Yes.
put the mixture of these the mixture of these amino acids inside or on a paper, and then we put the paper in solvent 1. This solvent has a specific density, but it will help us to what? To dissolve these amino acids. Type. What happens next?
The amino acids will be separated and migrate to the surface in the sense OA according to their degree of solubility.
According to their degree of solubility, they will start moving away from each other depending on how much they dissolve in this liquid.
Yes.
Okay.
Turn the filter paper by 90 degrees and transfer it into solvent 2 of different density.
Now you need to move the paper in a different direction, okay, and put it in solvent 2 that have a different density. What happens next?
Solvent 2 allow the migration of these amino acids in sense OB perpendicular to that of AO and in different speeds.
Now you separate them again at different speed, and finally
the above results are obtained.
طيب
Compare these results to a control panel where there is a separation of the 20 known amino acids.
طيب, let me explain it, okay, point by point, please, for those also who come with us now. For those who come with us now. Okay, let me explain it. طيب. I have, we all agree that I have 20 different amino acids. Okay, so first what I do, I bring these 20 amino acids and then I put each one of them on the chromatography paper to see how much, يعني the distance that each amino acid move. Okay, يعني مثلا leucine will move 2 centimeter. Alanine, another amino acid, will move 3 centimeter. Glycine will move 5 centimeter. So I record how much each of them, of the amino acids, will move. Then I bring a protein. I don't know what amino acids are found in this protein. I cut the protein into the amino acids, and then I put these amino acids on the chromatography paper like this process. Then I will see how much each one of them move. If I find one that moves 2 centimeter, meaning this is a glycine. If one that moves 3, for example, this is leucine. One move 5, this is X, and so on. So this is how I can identify them. طب, let me show you the video, okay, that I found about this, and then we can discuss it together. Okay. So, paper chromatography.
Basics here. Let's talk about paper chromatography. Paper chromatography is a common technique widely used for the separation of chlorophyll pigments, amino acids.
Now we will focus, okay, we will focus on, let's say, separation of amino acids. So this paper is going to absorb the solvent, the liquid. Okay, the paper is going to absorb the liquid. Type. First, you have the mixture of the amino acids. You put it in the on the paper, for example, in the middle. Here you have the mixture of the amino acids. Type. Let me explain it. The mixture of the amino acids. Now, what I do? Okay. Pay attention, Bas. What will happen? Okay. Now you put the paper in the solvent, in the liquid, but the liquid should not touch the drop that you put. Okay, should not touch the drop that you put. Now, the paper will absorb the liquid. The liquid will move up. When it will move up, it will carry with it the different amino acids. Type. Will all amino acids move in the same, let's say, speed, same, let's say, distance? Do you expect this? That they move same distance? No. You see? طيب, let me ask someone who can tell me which one of these 4 amino acid is the smallest. Or what color is the smallest amino acid? Yalla. What color is the smallest amino acid? Okay, let me see who give me an answer. The brown. Why, Adam, you say the brown is the smallest? Dam said the brown. Why, Adam, the brown? Yalla. Why you say the brown is the smallest amino acid? And others, do you agree with them? Do you agree with them about this? She said the brown. Others, do you think the brown is the smallest one? And why you think this? Okay, let me see. لأنه less weight, so it have a higher speed of migration. Very good, Ya Iman, very good. Since it is very small, so it will move more distance. Okay, the liquid will carry it more distance. That's why. Okay, the liquid will carry it more distance. So, everybody understand the concept now? How I separate them? So the liquid will carry them, but they will not move at the same speed together. They will move at different speed. طيب, why at different speed? Because it is the smallest amino acid. Let me continue. طيب. Now I will, let's say, improve this technique. Okay, I will, let's say, make it more accurate, more advanced. How? For example, Ahmed will tell me, what if two amino acids have somehow the same weight? And you all know what are isomers, صح? Isomers having same molecular formula, same, yes, but different molecular structure, right? طيب, what if the two amino acids have same molecular formula, but different molecular structure? How we can separate them? What we can do here? So I will tell Ahmed that I will do it now, okay, on the other side with a different solvent. That the solvent will dissolve this isomer but not the other one. So that's why they call it 2D chromatography. Okay, look here. 2D. First, you separate them. Now, Ahmed will tell me, for example, in the light green, there may be two amino acids that have the same molecular weight. أكيد, but different, different molecular formula. So what I do, so look what Ahmed did. He said, I will put it now horizontally in a different solvent. Now, in a different solvent that will separate the ones that have the same molecular weight but different solubility in the second solvent. Different solubility in the second solvent. Okay? So, clear for everyone? Well, I will repeat it. Yalla, let me know if there is anything you don't understand, please, in this process. Because it is a very important process. Yalla. Anything we don't understand? Any question about this? طيب, Khalid asked me to repeat. طيب, anyone has a specific question? Well, I repeat it from the beginning. حتى for those who came late. Okay, now the aim or the goal of this process is what? Is to separate, okay, is to separate the different amino acids that are found in a specific protein. هلا أنا these amino acids I cannot see them because they are all colorless. So I cannot depend on the color to separate them. I have to search for a different technique. Okay, I have to search for a different technique to separate these amino acids. So what I do now? What I do, I will depend on their ability to dissolve in a specific liquid. يعني some of them may dissolve more than the others. And also we will depend on their solubility and their molecular weight, so to see which one can separate from the other faster. Okay, which one of them can separate from the other faster. طيب, what I do now, I will repeat the video, okay, from the beginning to now see how I can separate these amino acids. طيب, first يا Khalid, I put the mixture of the amino acids as a point in the middle of the paper. This is not any paper, this is called the chromatography paper. يعني paper specific for absorbing liquids. Okay, a specific paper for absorbing liquids. It's called paper chromatography. طيب. Next, after you put it, okay, you put the paper in the first solvent, first liquid that will absorb these, okay, absorb these amino acids. These amino acids. طيب, a question for all of you. What happens if I put the liquid higher than the point? Yalla, let me see who can answer this. What happens if I put the liquid higher than the point? Who can answer? Suppose the liquid is higher than the point. Can anyone answer me this? If I put the liquid higher than the point, the mixture of the amino acids will dissolve in the liquid and it will not go up in the paper. Okay, it will not go up in the paper. So it will remain down. So that's why this will be a mistake. The liquid should always be lower than the mixture. Type. Now, okay, now the liquid will start going up. When it will go up, it will carry with it the different amino acids. Now, look, they separate them. Which one, Ya Khalid, is the heaviest one, the biggest one? The one that is less soluble? The one that is light green, the first one at the bottom. The first one at the bottom. This is the heaviest, the largest. طيب, now you will tell me here, Ya Khalid, at least I have 4 components. Okay, I have 4 components. طيب. Okay, now I want to check if there are any 2 amino acids above each other in the same point. In the same point. So what I do? Now, I will move directly to the video, the other video here at the end. Okay, first they move up. Then what I do? Then I turn the paper. If there are any 2 at the same point, they will separate. Look, at the first point I found a 3, and here 3, 3, 3, 3 in each. But now each one of them moved to a different distance. What I do now, I measure the distance from the original point. This distance will tell me now which amino acid is this, because each one of them will have a specific distance. Okay? Each one of them will have a specific distance. Clear, guys? Clear for everyone? Okay, any question before we move on? Any question? Others? Ahmed, Aya, Dam, Hadi, Yusuf, Khadija. طيب. Okay, فإذا I will stop sharing from here. I will go back to my page. So now, Iman, please, I want to read it from the beginning. Okay, I want to read it now from the beginning, please.
ارجع عيد من الأول.
Please, لنتأكد إنه everyone now understand clearly what he is reading.
Okay. In order to know the different kinds of amino acids that form the protein, peptide, or polypeptide, we have to apply double chromatography.
Okay.
Different amino acids have different molecular weights, so they have different degrees of solubility.
تمام.
So they migrate in different velocities. Less weight, more soluble, higher speed of migration. Based on this concept, we can separate these different amino acids given that they are immersed in a solvent fluid that permits migration of different amino acids each at a specific speed.
Okay.
هيكفي؟
Yes, please.
Deposit the hydrolyzed protein molecule at point O on a specific chromatographic paper, then immerse it in solvent 1 with a certain density. The amino acid will be separated and migrate to the surface in the sense OA according to their degree of solubility. Turn the filter paper by 90 degrees and transfer it into solvent 2 of different density. Solvent 2 allows the migration of these amino acids in sense OB perpendicular to that of AO and in different speeds. The above results are obtained. Compare these results to control panel where there is separation of the 20 known amino acids.
Okay. Clear now? Clear, everyone? طيب. فإذا please, if we have no questions about the process, let's start together answering these simple questions at the bottom. يلا. First, pick out the difference between the two solvents. What is the difference between the two solvents? يلا, who can tell me? يلا, who can tell me the difference between the two solvents? Any answer? So, the two solvents have different what? Solubilities. The two, okay, have different, sorry. Forget about this. Okay, sorry, this is the correct one. Have different what? Not solubilities. Have different densities. Sorry. They have different densities. Okay. Now, pick out the factor that allows distinguishing among the different kind of amino acids. What is the factor that allows to distinguish among different kinds of amino acids? يعني I depend on what to separate them. يلا, I depend on what to separate them. اوكي، فاذا amino acids are separated according to their molecular weight and weight and solubility. Very good يا خالد. Weight and solubility. أحسنت. برافو. فإذا according to the weight and their solubility. طيب, draw out the factor that affect the function. لا, sorry. Indicate the objective of double chromatography. So now, what is the objective of double chromatography? To know different kinds of amino acids. Okay, from where you get it, ya Iman? From the first sentence. فإذا the objective, of chromatography is to, let's write it like this, to identify the different amino acids that form a protein. Okay, to know to identify the different amino acids that form a protein. Okay. Is this clear? طيب. Let us read this application. Okay, let us read this application and we take it as a homework for next time. Okay, we will read this application and we take it as a homework, please, for next time. يلا. Okay, who wants to read? يلا. Who wants to read this part? Other than Iman. تفضل يا خالد. A bidimensional
chromatography is performed for a tetrapeptide
tetrapeptide. What do I mean يا خالد by tetrapeptide؟ يعني formed a protein of how many amino acids؟ 4 amino acids. طيب.
of individual X to obtain figure 2
Okay.
and for individual Y to obtain figure 3.
تمام.
Figure 1 is the control paper.
Control paper. What do you mean يا خالد by control paper؟ يعني paper انت you put in it amino acids that you know them مشان تعمل لك comparison. يعني لاحظ بالفيرست paper بالكنترول every point there is a name next to it. صح؟ مشان ليش في عندك هالنيمز؟ لانه انت here you do it for the known amino acids، يعني تعرف الامينو acids اللي انت حاططهم، فهيك صرت عارف انت كل امينو acid where its point. Okay, you know where its point. طيب كمل يا خالد please.
That is an already prepared sample that contains well-known positions of different amino acids.
Okay. كمل. Find.
بس هدول.
خلينا نقرا الكويستشنز just reading.
Find the amino acids forming this tetrapeptide in individual X.
فإذا find the amino acids forming the tetrapeptide of X. How you can know them يا خالد by doing what؟
Chromatography.
Chromatography. لا مثلا أنا in individual X paper you see it؟ طيب أنت عنده كم point مثلا الأكس؟ 4 points. طيب أول point من فوق فينا نعرف شو هو هيدا الأمينو أسيد؟ شو هو؟
aspartic acid.
aspartic acid. طيب كيف عرفتوا؟ أو ASP. خلينا نمشي على السيمبلز اللي هن حاطينهم. ASP. How did you know them؟
من الكنترول.
من الكنترول، يعني by comparing with the control. ما هيك؟ فإذا here how you identify each one of them by compare with the control. Okay? And then you continue the questions. Okay? Please, this will be a homework for Thursday and you should send it before Thursday. يعني today and tomorrow. Okay? Clear? يلا. See you Thursday إن شاء الله. السلام عليكم.